Operating a facility at 600 volts nominal in the United States introduces a set of considerations that differ from the more common 480 volt systems. Firstly, equipment ratings must be addressed. All equipment within the facility needs to be rated for 600 volts. Sourcing such equipment can sometimes prove more challenging compared to finding 480 volts rated alternatives, and the cost may also be higher. Secondly, longer lead times are frequently associated with 600 volts rated equipment. This is primarily due to the lower demand for this voltage level, which leads manufacturers to maintain smaller inventories. This factor needs to be accounted for in project planning and procurement. Voltage drop becomes a more prominent concern at 600 volts. The higher voltage can exacerbate voltage drop issues within conductors, particularly if they are not appropriately sized. It is critical to perform thorough voltage drop calculations to ensure that equipment receives voltage within its specified operating range. Arcing faults present a greater hazard at 600 volts compared to 480 volts. The increased voltage can sustain an arc for a longer duration, increasing the potential for damage and injury. Therefore, robust overcurrent protection and arc flash mitigation strategies are essential. Ground faults also pose a higher risk at 600 volts. The increased voltage can result in higher ground fault currents, demanding more effective ground fault protection systems to minimize damage and ensure safety. In addition to these potential problems, there are specific circumstances that need careful attention when considering a 600 volts nominal facility. The National Electrical Code, or NEC, outlines specific requirements for facilities operating at 600 volts nominal. These requirements include, firstly, all equipment must be rated for 600 volts, ensuring its suitability for the voltage level. Secondly, conductors must be sized adequately to manage the higher voltage and associated current, maintaining safe operating temperatures and minimizing voltage drop. Thirdly, the facility must incorporate a ground fault protection system designed to quickly detect and interrupt ground faults, reducing the risk of equipment damage and electrical hazards. Fourthly, regular inspections by a qualified electrician are mandatory to verify compliance with safety standards and to identify potential issues before they escalate. Insurance companies may also impose specific requirements for facilities operating at 600 volts nominal. These requirements can include, firstly, a higher level of insurance coverage to account for the increased potential risks. Secondly, regular inspections by a qualified electrician to ensure that the facility meets safety standards and that any potential hazards are addressed promptly. Thirdly, a written safety plan that details procedures for safe operation, maintenance, and emergency response. Before deciding to operate a facility at 600 volts nominal, it is vital to carefully evaluate both the benefits and the potential risks. If the organization is not fully prepared to address the challenges and specific circumstances, it may be more prudent to remain with the more conventional 480 volts nominal voltage. Several additional factors should be considered when making this decision. Firstly, the size of the facility. A larger facility will require more extensive equipment and conductor runs, consequently increasing the cost of operating at 600 volts nominal. Secondly, the type of equipment being used. Some equipment types may not be readily available with 600 volts ratings. If the facility design necessitates the use of such equipment, operating at 600 volts nominal may not be feasible. Thirdly, the availability of qualified electricians. Regular inspections by a qualified electrician are crucial for maintaining safety and code compliance. If access to qualified electricians is limited, it may be advisable to adhere to the more common 480 volts nominal voltage. The decision to operate a facility at 600 volts nominal necessitates careful consideration of numerous factors including equipment availability, lead times, voltage drop, safety concerns, code compliance, and insurance requirements. A thorough evaluation of these aspects is essential to determine whether the benefits outweigh the potential challenges and whether the organization is adequately prepared to manage the specific requirements of a 600 volt system. Implementing 600 volts electrical systems needs a strategic approach. Firstly, conduct a detailed load analysis to accurately determine the facility's power requirement. This analysis will help identify opportunities to optimize conductor sizing and minimize voltage drop. Secondly, collaborate closely with equipment manufacturers to ensure that all equipment is rated for 600 volts and meets the required performance standards. Request detailed specifications and documentation to verify compliance. Thirdly, design and implement a comprehensive ground fault protection system that effectively detects and interrupts ground faults. Select appropriate ground fault relays and sensors to provide reliable protection. Fourthly, develop a detailed safety plan that outlines procedures for safe operation, maintenance, and emergency response. Train all personnel on the plan and conduct regular drills to ensure preparedness. Fifthly, establish a regular inspection schedule with a qualified electrician to verify compliance with code requirements and identify potential issues early on. Address any deficiencies promptly to maintain a safe and reliable electrical system. Sixthly, coordinate with the local utility company to ensure that the facility's electrical system is compatible with the utility grid. Obtain approval for any modifications or upgrades to the utility connection. Seventhly, consider the use of energy-efficient equipment and technologies to minimize energy consumption and reduce operating costs. Evaluate options such as high-efficiency transformers, motors, and lighting systems. Eighthly, implement a robust preventative maintenance program to extend the life of equipment and prevent unexpected downtime. Schedule regular inspections, testing, and maintenance tasks to identify and address potential problems before they become major issues. Ninthly, document all aspects of the electrical system including equipment specifications, wiring diagrams, and maintenance records. Maintain accurate and up-to-date documentation for future reference in troubleshooting. Tenthly, stay informed about changes to the NEC and other relevant standards. Update the facility's electrical system as needed to comply with the latest requirements. Furthermore, consider the impact of harmonic distortion on the electrical system. Harmonic distortion can cause overheating of equipment, nuisance tripping of circuit breakers, and other problems. Implement harmonic filters or other mitigation measures if necessary. Evaluate the use of surge protection devices to protect equipment from voltage surges caused by lightning strikes or other events. Install surge protection devices at the service entrance and at individual equipment locations. Consider the use of uninterruptible power supplies or UPS to provide backup power in the event of a power outage. UPS systems can ensure that critical equipment continues to operate during power interruptions. Conduct regular power quality studies to identify and address any power quality problems. Power quality problems can cause equipment malfunction and reduce system efficiency. Evaluate the use of power factor correction capacitors to improve the power factor of the electrical system. Improving the power factor can reduce energy consumption and lower utility bills. Consider the use of variable frequency drives, or VFDs, to control the speed of motors. VFD can reduce energy consumption and improve process control. Evaluate the use of smart grid technologies to improve the efficiency and reliability of the electrical system. Smart grid technologies can enable real-time monitoring and control of the electrical grid. Consider the use of renewable energy sources such as solar or wind power to supplement the facility's power supply. Renewable energy sources can reduce reliance on fossil fuels and low carbon emissions. In addition, regularly assess the condition of electrical panels and switchgear. Over time, components can degrade due to heat, corrosion, and other factors. Replace or upgrade panels and switchgears needed to maintain a safe and reliable electrical system. Ensure that all electrical work is performed by qualified and licensed electricians. Improperly performed electrical work can create safety hazards and violate code requirements. Conduct regular safety audits to identify and correct any safety hazards. Safety audits can help prevent accidents and injuries. Provide ongoing training to employees on electrical safety practices. Training can help employees understand the hazards of electricity and how to work safely around electrical equipment. Establish a lockout-tagout program to prevent accidental energization of electrical equipment during maintenance or repair. Lockout-tagout procedures can protect workers from electrical shock and other hazards. Use appropriate personal protective equipment, or PPE, when working on electrical equipment. PPE can protect workers from electrical shock, burns, and other injuries. Maintain a safe working distance from energized electrical equipment. Maintain a safe working distance to prevent accidental contact with energized parts. Use insulated tools when working on electrical equipment. Insulated tools can protect workers from electrical shock. Never work on energized electrical equipment unless absolutely necessary. De-energize equipment whenever possible to reduce the risk of electrical shock. Follow all safety precautions when working on electrical equipment. Following safety precautions can help prevent accidents and injuries. Remember, operating a facility at 600 volts nominal requires a comprehensive approach that addresses equipment ratings, voltage drop, safety concerns, code compliance, and insurance requirements. By carefully evaluating these factors and implementing appropriate measures, organizations can safely and effectively operate 600 volts electrical systems. Consistent monitoring, diligent maintenance, and adherence to safety protocols are essential for ensuring the long-term reliability and safety of the electrical system. Staying informed about industry best practices and emerging technologies will enable continuous improvement and optimization of the facility's electrical infrastructure.